So this video is about the laws of exponents and how to use them and what they are. So first off, what is an exponent? An exponent is that small little number you see above another number. That's what we call an exponent. Now they can be any number, and it means that we're going to multiply whatever number this is by itself 2 times. So 2 to the 2 is 2 times 2. 2 to the 3 is 2 times 2 times 2. 2 to the 4 is 2 times 2 times 2 times 2. 2 to the 5 is 2 times 2 times 2 times 2 times 2, and so on forever. So exponents, again, are a way of describing how many times we are going to multiply a number by itself. So again, exponents are a way of describing how many times we are going to multiply a number by itself. All right, so now let's go over some laws of exponents. The first one, we're going to look at your book. So your laws of exponents can be found right here under a summary of how to simplify expressions with exponents, but this can be really confusing. So I'm going to just talk about them really simply, and we're going to discuss why they work. All right, so say we had this. We want to add 2 squared plus 2 cubed. That's what the 3 is called. The 2 is called squared. The 3 is called cubed. The others don't have names. They're just called to the 4th, to the 5th, to the 6th. But this, according to our rule, we add the exponent. If you look back at our rule here, it says that a plus m, so a plus n, or a plus n and a times n, sorry, this needs to be a multiplication. All right, so we're going to multiply. That's what that dot means. We're going to do 2 times m, or to the m, and a to the n. All right, so this is important because we have to have the same base. The number, the big number, is called a base. This is the exponent, this is its base. So we have to have the same base, and then we can add the exponents. We have the same base here, so this means 2 to the 5th. If we look at it this way, it's 2 times 2 times 2 times 2 times 2. Because here's 2 to the 3rd, and here's 2 to the 2nd. And if we add those up, we get 2 to the 5th. Now this principle also works when we're dealing with variables. Let's do another one. So you can always rewatch the video, pause it, and go back if you need to look at stuff. But we're going to do another example. We have 2x squared, and we have 3x to the 3rd. This should give us, after we do all the math, 6x to the fifth. Now, why is that? Well, these have the same bases. X is the base. 3 and 2 are just numbers out front. They don't matter. But x is the base, so we know we can add our exponents because x is our base. So we're going to take it and we're going to write 2 times x times 3 times x times x times x. So if we multiply our 2 and our 3, because this is 2x squared right here, this is 2x squared. This is 3x to the third. When we add everything up, so 2 times 3 is 6. And then we count how many x's we have. 1, 2, 3, 4, 5. So it's x to the fifth. Again, we multiply our constants, our two numbers that are the same, so 2 and 3, and then we count how many x's we have. So x is 5 because we have 5 of them, and you see those numbers match. All right, you can go back and look at that rule, but now we're going to talk about another rule. All right. Yeah, so we're going to talk about this rule. So this next rule states this: a to the m times n equals amn. So simply put, this rule means if we have 2 to the 2 times 3, or 2 to the third, sorry, so 2 squared and then cubed, this is the same as saying we're going to multiply those two together. And that's 2 to the sixth. So let me go over that again. This is the same as saying we're multiplying 2 by 3 to give us 2 to the sixth. But this rule gets more complicated than that. If we have a 5x squared and we want to square that, this is the same as saying 5x squared times 5x squared. Or we can take and multiply this 2 out, but if we multiply it to the x term, we need to multiply it to the 5. So we get 5 squared x squared. So we need to remember to distribute. It's distributing that exponent. So in a simple term, this rule is 2 times 3 gives you your new exponent. But really, it applies to whatever is inside there we distribute it to. And I'll go over more cases of these laws later. Right now we're just doing a quick rundown. So if we look at this one this way, this equals 25 x squared. And here we can see it equals the same thing because we've got a 5 times an x squared times a 5 times an x squared. Sorry, this should be x to the 4. So we have two 5s. That's 5 to the squared. 2 5s is 5 squared, 25. 2 x squareds, we can add those because of our other rule. So that's x to the 4. So we see that this rule distributes to each term. That's what you need to remember is this rule, if you have more than one term, so if we say we have ax to the m, we're multiplying that by an n. It equals a to the n x to the m n. And that's what we did down here. We took and distributed our exponent. All right, so now we're going to discuss one more rule, and then I'll make another one for division and negative exponent. We're going to discuss the exponent of 0. So 0 is a special exponent. So 0 is always going to make a number, so any number, equal 1. So if we take 1 to the 0, that equals 1. 2 to the 0 equals 1. 10,567 to the 0 equals 1. Anything to a 0 exponent equals 1. So that's the important rule for that. And we don't need to go into the reasons why. It's a long explanation why. But it's good to know anything to the 0 is 1. If you have, say, a 3x squared y squared z to the 14, and you take that all to the 0, it will equal 1. Anything to the 0 equals 1. And this is because we distribute the 0 here, each of these terms. So it becomes 3 to the 0, x to the 0, because we're multiplying 0 by 2, y to the 0, z to the 0, and that all equals 1. So those are some important rules. I'm going to make another video to discuss division and negative exponents. But you can always look at this chart. I hope it makes a little more sense. Watch this video a couple times until you get the concepts, and that will help you to understand what exponents are.